Yeah, perfect. Okay. So uh, once again, I'd like to welcome you all to the IoT 101 series. This is a session one. I called it Mwanzo. For those who are not Kenyan, Mwanzo is start in Swahili, and I'll be your host for this session. I'm Collins Nyegoti. Yeah, so okay, I'm looking forward for it to being an interactive session, and hopefully you can learn a thing or two. Yeah. So what we'll be covering today. So we'll have an introduction to. I'll introduce myself. I'll introduce the series and what we'll cover. There'll be a series preview of things that you are to expect if you'll be attending the IoT 101 series regularly. I'll also look into MLSA because this series is a partnership between MLSA and GOAT Technologies, of which we'll look into it. I know some of you might have been seeing things are being shared in the groups about GOAT Technologies, the blogs and etc. and wondering what is that. Yeah, then we'll get into the matter of the day or of the series, of which is IoT. So we'll do like a brief introduction to IoT. Then we'll do our ID setup because okay, it's a series, and that means there'll be subsequent sessions. So we'll be using a number of IDs for our project CTC. So it would be nice if I saw it would be nice if we set it up together so that people might not be wondering what is this, what is Wokwi, and what is platform IO. So for this session, it's just basically introductory and setting up things. Then, yeah, it's basically a beginner session. Nothing too technical. It's just like getting a clue of what this series is about. Yeah. Okay. For me, your hosts, Collins Negoti. I'm a okay. I'm admitting people. Hey, Ian, do you have admin privileges? You can assist in maybe admitting people to the call because it's a bit distracting. Though I can handle it, but if you do have it, if you do have admin privileges, I'll appreciate if you had to help me with that. Yeah, so I'm calling Nyegoti, an embedded system, IoT and embedded system developer, of course. I cannot be hosting a session on IoT if I'm not an IoT developer. I'm also a beta MLSA. MLSA in full is Microsoft Learn Student Ambassador. Yeah, so I'm a beta level. Beta is like the second level, second or third. Okay, depending on where you look at it. Yeah, I'm at beta level. I'm also the chapter lead of MLSA Decode. So okay, we look into MLSA, but okay, currently I lead the MLSA chapter at the Kimathi University. I see we have a number of MLSAs here. Ian Duncan, the Silas, I've seen him in the call. They are members of my team, and we do host sessions like this. I'm also the co-founder of GOAT Technologies, of course. Yeah, and last but not least, I'm a mechatronics engineering student at Dedan Kimathi, of course. That's my picture there. Though currently I don't have the afro. I had to shave cause of a stupid bet, but yeah, that's still me. If you saw me somewhere, you still recognize me. Yeah, I believe now you have a understanding of your hosts and etc. I've seen a surprise introduction, emoji from someone. Okay, people who know me I used to me with the afro, but you'll have to get used to me with the low cut. Yeah, introduction to the IoT 101 series. Okay, so what we had in mind with this series, we wanted it to be a community series. It's not about me coming to teach you things. It's not a teacher-student kind of series. We wanted it to be a community peer-to-peer. So someone has their mic unmuted. We need to be a community series, peer-to-peer, which will be covering everything IoT and embedded systems. If you don't know what IoT is, don't worry, you'll get to know with time. If you don't know what embedded systems is, with time you'll get to know it too. Series scope will have beginner sessions on IoT. IoT being Internet of Things. Beginner sessions will be covering from the basics of the basics to advanced stuff. We'll also be having mini projects because okay, being an MLSA, one thing that I've noticed is sessions are more what can I call it? Are more passive. Like you just come and see what's happening, and it's more passive. It's more like third party. So with this, we saw it will be different if we have mini projects. So like you as the audience can get to engage and build things and see how they work, so you can learn better. So I'll create a GitHub repo where we'll be posting our work. So if you're in our group, uh, I'll share it within the week. Let me share a link to a group for those who are not part of the group. So that WhatsApp group will be the like central communication point. Let me share the link to the WhatsApp group. So if you're not a member of the group, so kindly join. We'll also have C++ sessions because IoT and embedded systems mainly is done using C++, and that's the language that I'm conversant with. Okay, it can also be done with C, embedded C, but I'm not that conversant with that bit. But if we get someone who can cover it, we'll also look into it. We'll also be having show and tell session. As I said previously, it's a community series, so it's not me coming to show you things. If you have a cool project that you have worked on, this will also be a platform where you can come and showcase the things you've done, updates on the trends and things that are happening. We'll be covering it here. We'll also be inviting guest speakers, someone from the industry, etc., someone knows something that we feel that will be beneficial to the community and the series at large. So basically, that's IoT 101 series, and I'm looking forward to seeing you each and every other week, and so that we can learn, interact, and grow together. Yeah, and if you have a question or anything, just you can unmute, raise your hand or type in the chat. As I said, it's a peer to peer. It's not me coming to tell you things. I like to hear your side of things too. Yeah. Yeah, so on to the next slide. Okay, session partners. This series is brought to you by MLSA, the Microsoft Learn Student Ambassador, and GOAT Technologies. Okay, I'm part of both, so I'm kind of like the bridge between the two. But yeah, it's brought to you by these two incredible. Should I call them parties? Okay, one is a community, the other one is a startup. Yeah. Oh, okay, we'll look into them in the coming slide. So these are the people these are the like you brought to you by, okay, both don't have are not financially well off, so I cannot say the sponsors, but these are the people organizing this. Yeah, MLSA in full is Microsoft Learn Student Ambassadors, and it's a global initiative by Microsoft. You know, Microsoft, the big conglo the big company. And they put the initiative is to empower students who are passionate about tech with access to resources. The resources being Microsoft Learn, LinkedIn Learning, M365, training. Okay, it's also there. The opportunities okay, to build technical skills, collaborate on innovative projects. So what does being in this community entail? The first thing is collaboration. When you're in this community, you get access to like numerous people who have the similar interests, where you get to share knowledge, work together on projects, and just grow together. Another thing is networking. You get to build connections with like-minded individuals like, okay, via this series I'm hoping to like get to know a number of people. So I'll say this series organized by MLSA is a channel to network. We'll be working on mini projects, so you can see where the collaboration is coming from. Uh, wow, that's an alarm for me to do something. Just a second. Sorry about that. Sorry about that. That's something I had to do. Collaboration. Okay, using this series as an example, this series is brought to you by MLSA. You'll get to collaborate on projects. So that's the collaboration. The networking, hopefully with time, as you get to collaborate, you get to know each other. The networking, there's also the learning where you stay up to date with the latest trends and technologies. From the series scope, you can see that we are covering those elements that I've mentioned here. So basically, now like enlarge it from the IoT 101 to just a whole community of which that's MLSA. It's basically the same thing. So okay, next I have like a video. So if you haven't like understood what MLSA is all about, I have like a video here like explaining about the community and etc. Okay, from there it's irrelevant things. Okay, not related to what we are to cover here. Okay, am I audible? Maybe I'm not learning from a previous session I had. It's nice to confirm if people can hear you. You can find you're talking to yourself. Okay. Yeah, so basically that's it. I believe the video has given you a clue of what MLS is about. I've shared a link to where you can apply to be part of MLSA. We also have an MLSA support group. So if you are unsure of the how to join, we also have a group where you can join and we can guide you on becoming an MLSA. Let me share a link to that. Maybe someone might need it. But the link I've shared in the group currently, it's the link to the MLS application portal. It's not hard to apply, but okay, there are a number of steps to join, but I like for you to join the program. That would be nice. Okay, pardon the silence. I'm looking for the link to the support group. Yeah, perfect. There it is. So anyone interested in joining MLSA, you can join that group, and we can guide you through the process, etc. Yeah, GOAT Technologies. Wow. GOAT Technologies is a startup based in Nyeri, where we build smart solutions that are for personal, commercial, and industrial applications. When I say personal, okay, it means something. If you might need like a device, okay, it's based on embedded systems, but it covers a number of things. So personal, for your needs, for your business, industrial, if you have a company that needs to like automate something, we are the people for you. Uh, we have like a tag, a trusted partner in everything IoT. If you need anything IoT, we are your guys. For our services, it involves hardware manufacturing. By hardware manufacturing, we mean PCB design, PCB printing, PCB assembly, card design, yeah, card or 3D printing, yeah, basically everything hardware. Sourcing, we can also source for you components, everything you need. IoT development, IoT basically is the connectivity. If you need to like integrate IoT in your system, or have builds as a device that has IoT, we do IoT development. We also do software development, that's building website, application, systems. We've done a number of systems like the management system. That's okay. That's our product. It comes as a twin. The GN1. GN1 is a clocking device, a biometric clocking device, and it comes with an attendance management system. So institutions like schools, businesses, they can be able to track their employees, their students via the system. You also have got MPPT. This is a solar charge converter, and it's using the MPPT algorithm. MPPT is maximum power point tracking. Okay, I won't get to the technicals of it because this session is supposed to be beginner friendly. So, but this is GOAT Technologies, and with us here I have a partner of mine. Okay, I'm part of GOAT Technologies. I said I'm like the bridge between MLSA and GOAT Technologies. So, yeah, but just to like provide a different voice to what we do, we have a partner of mine, Sam. Yeah, we work with at GOAT. Some like, can you like unmute and say something about yourself and what we do at GOAT?
Yeah, I hope I'm audible. Yeah.
Yeah, we can hear you loud and clear.
Yeah. Okay. So my name is Samuel Macau. I'm also a co-founder at GOAT Technologies, and as Collins has outlined, we deal with everything regarding IoT. So everything ranging from PCB design to the systems that these PCBs hold. So we are like we design everything from the hardware end to the software end. So that is basically what we do. Currently, we have products, some which are under development and some which are ongoing. Are almost ready for the market, and that is GUN1 and GOT MBPT. Also we have partnerships. I don't think if this was mentioned. We have partnerships with a different company with which we produce we produce software systems. So basically that is just a brush of what we do. So with this session, I believe it's very IoT oriented.
Yeah, there you
So
have it. There you have it.
yeah.
Oh, oh. I hope I've not cut you short. If you can continue, if you're continuing.
No. That was all I had to say. Thank you for the
Oh, oh,
opportunity.
cool. Yeah, oh, yeah. Yeah, we also work with Beyond Gravity Solutions, and we build together with them a number of systems. We have the Learnify, it's a e-learning platform. We're working together on also KMS. KMS is a kind of like a circle platform, but these are things that are currently in development, so I cannot share too much about them. But uh, we have a number of things going on, and it's pretty interesting. It's pretty interesting. Okay, personally, I work on the embedded. Okay, embedded part. I write the firmwares for the GUN1, got MPPT. That's my area of specialization. The people who do other things, like some is the electrical guy, he designs the PCB, etc. Yeah, everyone has their specialty, and hopefully from this session also you can find like where you belong. Okay, what you're good at. So those are your sponsors, Go Technologies. I've shared a link to our website, so you can check us out and yeah, hopefully learn a thing or two. Now we get to the matter at hand, the important part, IoT. What has brought us here together? So I'll break IoT up to parts so it can be easily understandable, because Internet of Things is it's like a compound word. They've joined a number of things, internet and things. So what is the internet? The internet is a global network of connected computers and servers. They they that communicate via standard protocols, which is TCP/IP. Yeah, and what are things? To v two, what's to v two? What are things? Things are physical objects or devices that are embedded with sensors, software, and connectivity. So basically, things are devices, electronics. Uh, I think you get what I mean by that. So when brought together to form IoT, so what's that? So when internet and things are brought together, they form a system of interconnected things or devices that communicate via the internet. And when they communicate, they share data, and they enable to automate process, and enable also remote monitoring and control. So I have a simple analogy that I normally use to explain this. So the internet is like a highway system. It's like a path where data and etc pass, and things are like the cars, the devices, the cars passing through the network. So uh, IoT in general, it's the traffic management system. Like, okay, we can call them the traffic police, etc. Okay, that's like an analogy to help you understand what IoT is about. Though basically IoT only explains the communication and the data sharing part. So when you do IoT and embedded system, so embedded system is just building the things part. There's the things and there's the internet part. So embedded systems is the things part. Those things that share data are able to communicate. So that's building those. Okay, those things are embedded systems, and building that is embedded systems. When those systems are able to be integrated to the internet, they become IoT devices. I hope now you have a better understanding of what's IoT and embedded systems. Okay. Uh, any questions? Any questions up to there? Okay, none. So what are the components of an IoT system? The first one is devices and sensors, the things part. Uh, Devices and sensors being the microcontrollers. There are a lot of microcontrollers. The ESP. Okay, I'll just mention the popular one, the ESP32, the Arduino, and the Rasp. Though basically these three are development. I'll say development kit. Development type. Okay, I'm looking for the word. I'll say basic type. When you get deeper into embedded systems, you find that you'll be working with the chipsets. You find like an ESP, it's already a board it's a microcontroller. If you okay, for people engineering, they know the difference between the microcontroller and the microprocessor. So these are microcontrollers. When you get deeper into embedded, you find yourself working with the microprocessors. Basically, it's just like a chip. like the CPU, and from there you have to build everything around it. But for the microcontrollers, you find that it's already like it has the RAM and everything in place, so it's easier. We have the actuators. Actuators basically are things that provide the physical motion. Okay, that doesn't explain it well. Actuators are things that turn command into reality, into physical movement, if I can say that. That being motors, relays, smart locks. Okay, smart locks is an IoT, but I hope you get the sense of it. And there's the sensors. Sensors basically things that help the machines perceive the environment around them. The second part of an IoT system is the connectivity. Connectivity, being able to connect the others via Wi-Fi, Bluetooth. Okay, there's short range, the Wi-Fi and the Bluetooth. Is the long range, LoRaWAN. LoRaWAN being long range, low power, while wide area network. There's the cellular. Cellular is basically the data, the normal data, Airtel stuff. There's the communication protocol. Communication protocols is like different situations require different communication protocols. Like the HTTP, this is basically like the similar to what uh, websites use, the way the request response. There's the MQTT. This is the subscribe and publish type of protocol. And also there's the another component of IoT is the cloud and edge computing. So, okay, these are components, and also I can call them branches of IoT. But for this case, let us like uh, group them as components. So for cloud, it's the centralized data processing and storage. By this I mean your device is connected to the internet, where it sends data, and the data is processed on the cloud, and it communicates back to the device. And this can be done via AWS IoT and Azure IoT. We'll cover Azure IoT later, a bit later. And also there's the edge computing. By edge, it means the device doesn't like communicate directly to the cloud. It communicates to an edge device. An edge device, it's okay. Let me use an analogy to simplify this. So maybe you have like 10 computers, and this in cloud computing, all these 10 computers are connected to the internet. But in edge computing, all these computers are connected to one computer, and that one computer is regarded as the edge device that's connected to the internet. So the others, this is done for to increase security. All the other devices are not connected to the internet. They're connected to one device, and that device connected to the internet. So it does the local processing near devices. Okay, I don't know what I was saying there, but yeah. An example of this is the NVIDIA Jetson Nano. Yeah, that's used for edge computing. Has a lot. There's Edge ML. Okay, there's a lot we'll cover. We'll cover in future. Okay, IoT is pretty interesting, pretty wide and pretty interesting. Okay, I like incorporating videos in my sessions because I know like I'm not that good with words, so I like to add a video to like maybe explain something that I was not able to capture well. Yeah, so I have a short video on IoT, and hopefully if there's anything you've not understood, it will help with that.
The Internet of Things.
come and master IoT with IoT 101 series, not Edureka. Yeah. Okay. Okay. As they were mentioning the use case, I remember there's a blog that we did recently. Okay, on Monday, that covers IoT and the Industry 4.0, the fourth industrial revolution. As you all know, we are in the fourth industrial revolution currently, and I did a blog that covers like how IoT is affecting the fourth industries and economy in this Industry 4.0. And if you can get time, just like go have a look at it, and hopefully you can learn a thing or two. Yeah, as you've seen from the video, IoT is all around us. Basically, almost everything, even your phone, is an IoT device, but most people don't know it. Right now, there are smart fridges, smart homes, smart everything. Everything is smart. Sadly, the people are not getting any smarter, but at least our devices are getting smarter. So a win is a win. Yeah. Yeah. So next we look at the real world applications of IoT, the Internet of Things, and the first is smart homes. As okay, right now the homes that are being built, like the real estate, they have a lot of IoT in them, from the smart lighting, the automated lighting based on occupancy. An example is the Philips Hue. This is the security camera that are AI powered. At the same time, they are connected to the internet to transmit the data, so you can see from anywhere what things that are happening in your environs. Uh, I have an example being the Ring and the Nest. Yeah. If you get time, you can just go have a look at the examples that I put, because pretty interesting stuff. There's the voice assistant, the Alexa, the Siri, the Google Home. Yeah. And how are these impacting? The first one is energy saving. For example, the Philips Hue, you find that the lights are automated such that when there's no one in the room, the lights are off. So saving on energy. Another one is convenience. Convenience is self-explanatory. Security, the security cameras, self-explanatory. Yeah, sure. Okay. If you have anyone who has a question, it will be nice if like you ask something, but it's still okay. Hopefully you're learning. And the second application, it's in healthcare. In healthcare with wearable devices, like the Apple Watch, the Fitbit. These are things that track your heart rate, sleep. Okay, I know we are in 2025. Majority of you have interacted with smartwatches, so I don't need to explain that a lot. There's the remote monitoring. Currently, there are a lot of like remote monitoring devices. There's one for the diabetes. I know one for blood pressure, etc. Yeah. Okay. Uh, for healthcare, that's something that, like, as an embedded systems developer, that's something that, okay, it really like it's something close to my heart, because I imagine like building something that is helping people, like keep people alive, and helping people get well, and it feels good to know that your device is somewhere out there helping someone who is special to someone stay alive. But that comes with a lot of constraint, because they have to be like near perfect, because a slight fault, imagine something like an heart pacer, that if it's faulty, that's a huge loss. But yeah, I hope you get the point. There's the emergency alert, the fall detection for the elderly, like life alert. Okay, I know friends of mine who did something similar to this, though it was for kifafa. How is it called in English? Okay, the name is epilepsy, for epilepsy. Impact is predictive care, and reduced hospital visits, which is a good thing, because it reduces the burden on our hospitals and our doctors who are currently on strike. So you see, we are helping the systems, because even if you go in the hospital, there are no doctors. Yeah. Another application is in agriculture, where there's the smart irrigation. soil sensors optimize water use, e.g. CropX. But they should go look into this. They're pretty interesting projects. There's the livestock tracking, GPS collar for herd health, Kaola. I like that name. I also worked on a project similar to this for a hackathon. It was called CareSync. It was something that could monitor the health of the herd at the same time tracking them. Yeah, though we didn't win, but another project of us won, so win-win. There's the drones that okay. These are like a field of tech called precision farming, where basically the you farm by providing each plant with what it needs. Like okay, precision farming. Sorry for the silence. I was admitting someone to the call. I was admitting someone to the call. Precision farming, and it helps to increase higher yields, resource conservation. With the increasing population and the diminishing land for agriculture, we have to optimize and like make maximum use of the little land we have to feed the many people, the many hungry people we have. And another application is the Industry 4.0. Industry 4.0, I'd mentioned it in the blog. So how is IoT being used here? It's being used for predictive maintenance, in which sensors are able to detect failures before they can happen. Another one is asset tracking. The video that I played you, it explains this very well. Using RFID, GPS, they can able to like track everything. If you've ordered something via Jumia, Alibaba, you have a clue of what I mean by this. You can see where your asset is. There's the automated warehouses, uh, robots and IoT for inventory management. Basically, there's things called AGVs, automated guided vehicles, and they use IoT kinda, so they're able to like manage things in the warehouse, move things from point A to point B, reducing the need for human interference. So what are the impacts of this? One is reduced downtime, another one is cost efficiency. Wow, wow. Uh-huh. I see we are time is going, and we have to do our demo. So the our final step was to set up our IDEs, of which these are things that if you're a developer, majority of them, okay, like VS Code. I believe a majority of you have VS Code. If you don't, you can download it in the link. Let me share the link, or you can download VS Code. So the things that you will be using is one VS Code, and if you don't have it, you can download it via this link. And our second IDE will be Platform IO. Platform IO is like an upgrade to Arduino IDE. Arduino IDE it has its own limitations. First of all, it only uses the Arduino platform, and if you're working in embedded, as I mentioned, you'll need to work with chipsets, and Arduino IDE can't work there. Another thing is collaboration. Okay, it's hard to work on large projects on the Arduino IDE because maybe the dependencies, the header files, etc. It becomes a mess working with Arduino. So we'll be using Platform IO. Platform IO is it's more organized. I'll show you how it looks and works. And we'll be using another thing we'll be using is Wokwi. Wokwi is an IoT simulator. It's an embedded IoT simulator. You can simulate any microcontroller, the ESP, the Arduino, the Rasp. You can simulate any microcontroller on Wokwi, because this is a virtual session. So, and also currently I don't have any components, so I saw it wise to use Wokwi. Yeah. So for this session, I'll show you how to set up. Okay, for VS Code, I don't think that's necessary. For VS Code, I don't think that's necessary. I'll show you how to set up Platform IO and Wokwi, and connect your Wokwi with Platform IO, so you can you can like work directly from your IDE, because working with Wokwi on in the browser, it's limiting. It's very limiting. So yeah, so we go to our demo. Our demo will be kind of switch, because it's not that complicated. It's just like installing extensions. Platform, oh, by the platform is an extension on VS Code. I don't know if I mentioned that. So yeah, so let me like share my whole screen. I was sharing the slides, so let me share my whole screen. As you go to the demo, any questions, any clarifications that is needed? Mm. Can you see my screen? Kindly react if you can see my screen. Can anyone see my screen? Okay. Oh, sure. Yeah. So I've shared my entire screen. So as I said, you can download VS Code here if you're using Windows. If you're using Ubuntu like me, you can download the dev file or RPM. If you're using Mac, okay, for VS Code, that's self-explanatory. Uh, Another thing we'll be looking into is Platform IO. Platform IO. I think I had a link to the other site. Yeah. So Platform IO. Uh, it's like an IDE. It's an extension on VS Code. Let me show you. Yeah. So okay, this is the Platform IO portal, but it's an extension on. So if you go to VS Code and search Platform IO, it will appear here, and you'll have the blue install button. Okay, I've installed mine already. I thought of like redoing the whole process, but it takes like a considerable amount of time, so I thought not to. But for the okay, let me go back to my screen and show you. So Platform IO, it's a nice platform for doing the embedded system, because they have 40 plus platforms. By 40 plus platforms, I can call them like microprocessors, the Arduino, the STMs, the ESPs. Yeah, they have a lot of platforms which you cannot get on uh, Arduino IDE. They have like 20 plus frameworks. Okay, don't confuse frameworks with platforms. Framework is, how can I call it, like the okay, I usually lack words to like the how your code will look like, depending on different microprocessors have take code differently. So yeah, they have 20 plus frameworks for the different platforms, 1500 plus boards, 13,000 plus libraries. It's pretty interesting. When you install Platform IO, let me just clear up my screen so you can see better. Let me mm, remove. Perfect. Perfect. Wow. I don't know why demos must have things must go wrong somewhere. Now what's wrong with my VS Code? Was not to show that code. Okay. Console. So when you install VS Code, you'll get that this alien. I don't know, it's alien or ant looking like icon here. So when you open it, let me like clear things. My VS Code is a mess. Uh, when you open it, the home tab looks like this, where you can create new projects here. You can import. The good thing with Platform IO, you can, if you are working with previously with Arduino IDE, you can still import your Arduino projects. You can open previous projects. There's the examples. You also have news. There's a list of your previous projects here. There's the projects tab. This is where you'll find all the projects you're working on. There's the inspect tab. This way you can look at your projects, the amount of space it's taking, the platform you're using, the microcontroller it's using. Libraries similar to Arduino. This way you can download your libraries. Though there are two ways of working with libraries, but this way you download them. Boards, these are you select your board. If you're using an ESP, your Arduino, Rasp, any kind of board you are using, this is where you get to select the boards you're using. Platform, this is the, as I'd said, platform is the microprocessors that a board is using. If you're in the session, like from the beginning, there's the microcontroller and the microprocessors. The microcontroller it's something component. There's the microprocessors, like the heart of things. So the platform, it's where you get the the microprocessors that you'll be using. You get to choose them. And here on devices, this is where if you connect your device to your laptop, it is automatically detected here. If you worked with Arduino, it's kind of similar. Where on the top in Arduino, it's on the top somewhere here, the devices, but for Platform IO, it's here. So when you're creating a new project on Platform IO, you find you can write a project name. You select the project you're using, the board you're using. As I'd mentioned, there are over 1,500 boards. There's a board I like to use. Where is it? ESP dev kit. What is that board? This is just an example. So framework. So because we're using an ESP, so the framework that are here, it's Arduino or ESP IDF. Yeah. So okay, ESP IDF is kind of technical. So Arduino, I'm just showing you how to create like a project on Platform IO. But although these are like basic stuff, but yeah. So it takes like a minute to load. But if for your first time like installing Platform IO, it will take forever. So don't be surprised. Why is it taking this long? This JSON file. Yeah, so when you open Platform IO, you'll get these files. The PIO, this you don't need to configure it, because it's just showing you like the board that you're using. I don't know if you saw, we chose ESP32 feather, so this is where it appears. So these are things that Platform IO configures for you. It's a JSON file that contains that information, and also there's a .vs code file. It contains the configurations for VS Code, your Platform IO on VS Code. So these are things that you don't need to configure. You just leave them as they are. There's the include file. This is where if you're working on a large project, you'll have your header files here. Header files, okay, there's no need to get into details, but this is where you have your header files. As we continue, you'll get to know what header files are. Yeah, there's a brief readme here to show you how to arrange your things. Wow. There's the lib file. This is where you'll have like your there's some projects that you find that they have like some subfolders that you need to work with. So to have like your code more organized, this is where you'll have the subfolders. And the SRCs, this is where you have your source code, and these tests, because okay, for embedded it's more test oriented, because you need to like make sure things are working as they should. So this is where you have your test cases. Yeah. If you look down here, there are like this trash can. This is if you've compiled your code, compiling happens up here. You can build, upload, tests, clean. Okay, this clean, it's also down here, what I was to explain. So if you compile, the clean button is used to like uncompile and like clear your IDE. The test, if you're running tests, it happens here. This is the serial monitor. It's used to like give like to feedbacks, but you have to set the baud rate, kind of similar to Arduino. But so this is where you can access your serial monitor on platform IO. Yeah. Is there anything I've not covered? Gitignore. Gitignore is it's the normal Gitignore things that if you're pushing your code that will not be pushed to GitHub. Platform.io.ini. So this is the configuration file for platform.io for different projects. So you can see like the platform you're using is ESP32, the board, yes. Oh, this is the perfect example to differentiate between board and a platform. You can see the board that we are using is the Feather ESP32, but the platform we are using is the ESP32, the microprocessors. Yeah, so don't differentiate between the two. The framework we are using is Arduino. Oh, the perfect way to see this is when you open the main.cpp. You can see this header file. It's showing that you're using the Arduino framework, and you can see like the normal void setup, void loop, which are for Arduino. Okay, I've seen that like there's someone requesting to join. Sorry about that. Yeah, so basically that's like the normal things that, okay, to make things easier, let me open platform.io on a project that I've already done so that you can see how files are configured there. Let me open this. Taking a second to open. Okay, as we wait for it to open, let me show you Wokwi. Not this window. So yeah, Wokwi is an online ESP32 simulator, but though it has a number of boards. There's the Arduino Uno, Omega, Nano, the ESP32, there's the STMs, the RASPs. It can work with okay, you can work with it on VS Code, which we'll be doing. You can work with it on CL, JetBrains. Yeah, it can also do the work with Rust, MicroPython for those who are working with Python. But personally, I'm a C++ guy, so yeah. You can get featured projects. These are unnecessary things, but we'll get to that soon. Yeah. You see the project has open. As you can see in the include files, I have my header files. Okay, this is the code for the clocking device that the given one. This is the source code. Yeah, these are things that I'm not supposed to be showing, but okay, why not? Yeah, so like these are the header files. You can see I have my header files here. You can see I have my header files. The libs. Okay, I don't have any like libs here, but yeah. And the source codes, they're here. So you can see like a project like this, if you're working on it in Arduino, it had to be it will have had to be like monolithic, like one long, or if you add it modular, it will be hard to like keep track of things because you won't know where everything is. So you find here these are the source code and the main ccp.ino file. You see, this was an Arduino. It was an Arduino code, and you can see the platform ini for this. I'm using ESP32. This is the board I'm using. I'm using the Arduino frameworks, and these are the libraries that are currently installed. Yeah. So I guess that's all with platform.io. I don't know if there's anything I haven't covered or if there's any question on platform.io. Any question on platform.io as we shift to Wokwi? Okay, no questions. Okay, either I'm a good teacher that there's no questions, or or you're not hearing me, or Yeah. Okay, so Wokwi is an embedded systems and IoT simulators I've mentioned. Okay, let me just uninstall and reinstall it so that you can get like the gist of how it works. So let's home. There's a project that I wanted to use for this example. Give me a second. I just clear out my, yeah, perfect. So is it installed? Yeah, it's installed. No, not there. So Wokwi. Let me go back to the. So Wokwi, when you're working on it in the browser, it looks like this. Let me choose the ESP-2. When you're working with it on the browser, it looks like this. So you find you have like, okay, it's using the Arduino platform. So you find that it's not platform, framework. When you have the source the code you're writing with, it's your writing is on the right, and the components are here. So this is the microcontroller, the ESP, this the pins. Okay, who has never like seen an ESP? So the components, you can choose like any other. We'll be using it this often, so you can choose any component you want to work with. You just choose it, and you drag and drop there. Maybe it's a resistor. You can join things. Okay, this I'm just doing like, not really like joining them, but I'm just showing you how it works. So basically this is it. But you find that when you're working with it on the browser, it's a bit limiting, because as you have seen, like from like for the clocking device, that's like a lot of codes and files, and yeah, so working with it here, it's limiting. So there's a way that you can connect it to your VS Code, extension, your VS Code. And when you're connecting the VS Code extension, every project you have to ensure that it has this wokwi.toml file. So this is like the file that links your Wokwi on the browser with your project on platform IO. So as you can see, this file here, lf, is the file when I run this code. When I run this, just trying to demonstrate something. It's building. So this ELF, it's like the application. You'll find it down here somewhere. I just want to run and build so that when you're doing it, you don't like wonder where can I get this path. So when you build your file, there it is. You can see here there's though it has not completed building, but you can see that here is the ELF file, and there's the .bin file which will appear when it's complete. Yeah, it's successfully built. So when you write your code and build your project, and you want to simulate it on Wokwi, so first of all, on this Wokwi.toml file, you'll need to take this ELF and paste it here on the ELF. What is it called? That space there, and the bin. Okay, for bin, I cannot locate. It's usually somewhere there. Oh, here it is. But though, regardless, okay, the ELF and the bin, only the extension are different. So if you find the ELF, you just change the extension. And another thing is, once you've built your project on Wokwi, like you have connected everything, there's this JSON file. This JSON file is done that is used to show how things are connected your Wokwi. So like you'll have to create a .json file. No, it's created on the wrong place. Yeah, perfect. So you'll have to create your JSON dot. So this the function of this JSON, why is it having, it's supposed to be blank. Supposed to be blank. I don't know why it has this connection. But yeah, okay. So what I was trying to explain is this JSON file is the one that is used to show like your platform IO, how different components are connected. So for this this is like uh, how can I call it? It's basically a lighting the bulbs, but we'll do it via a web server. If I run this code, you'll see what I mean. So when you connect your, okay, mine has come there automatically, which I did not want. But you'll find this code, and this code you're supposed to copy and paste it in the JSON file, so that your platform IO can locate the components, and via this ELF and firmware, your Wokwi can locate the platform IO. So you can see how the two softwares are finding each other. Yeah. So basically that's how it works. Let me like build this. No. I'm supposed to build it. I had already built it. Okay, let's just like run it, so you can get like a gist of how things work. Let's see if it runs. Yeah, it's running. It has to open. It's connected to Wi-Fi. Yeah. So if you go to, I'd already opened this page. Where is the localhost? Yeah, it is. So you can see when I turn LED on, you can see LED one is turning on. So basically that's as you're seeing it, that's like IoT, being able to control things from the internet. Off, turns off. Though this one is working on the local hosts, but I think you get the point. So the code that is lighting this is this one. You can see like I've mentioned the pin that I'm using is 20, 26, 27. Yeah. I've set up LED output, yeah. And the JSON file is where you see like your simulation in real time. It's supposed to be on. Why is it not lighting? Oh, I stopped simulating. I'll have to rebuild it. Yeah, but I hope you're getting like how things are happening. You can see LED one. So with time we'll be working on like cool projects such as this. But for today, I just wanted like to show you the Wokwi simulator, platform IO, and yeah, and introduction to IoT and the series etc. Any questions? So far? Let me go back to my slides. Any questions? Am I audible? No, you might find I was talking to myself. You know, I have PTSD of some session I had about a month ago. Ah, I talked to myself for like almost 30 minutes. Well, the audience can hear you. Where are we? Where are we? Where are we? Yeah, Q&A, Q&A. Can you see my slides? Yeah, so yeah. Any questions so far? We are in the Q&A session section. Any questions? Okay, if there are no questions, can I ask a question? Okay, I just have a simple question, like how Platform IO and Wokwi are able to like locate each other. By what means is Platform IO and Wokwi able to locate each other? Anyone who can like explain that? Okay. No one. Okay, anyone wants to say hi to people? Tough crowd. Okay, if I say there's a giveaway. Okay. If there are no questions, I just give myself a tap in the back and just tell myself that maybe I'm a good teacher, that you are able to understand everything. But hopefully, I hope there's no one who has a question and it's just quiet. If you have a question, just share so that we can. Okay, any how is it called? Any like remarks? Anything you want to say? Anyone wants to say? Because we are like currently concluding the session. The session was to end at 9, but we have extended by almost by 20 minutes, 20 plus minutes. So yeah, I'd like to like conclude there. Hopefully from the session, I hope you have understood the things that we are to cover here. You have understood what is MLSA, or you have understood what uh, IoT 101 is to cover. You have understood what MLSA is, what GOAT technology is, what IoT is, and how the IDEs will be using, how they work. I hope you have understood everything. So with that, we are concluding our first session, session Mwanzo, and I'm looking forward next week, same time, same place. We'll have another session, and I'll communicate on what the session will be about, and I'm looking forward to seeing you in our second session. We'll be having sessions weekly unless something comes up, but from today henceforth weekly. Next week I'm thinking of shifting it to Monday, but I'll confirm to that and share in the group. If you want to be part of the group, kindly join I've shared our WhatsApp link to our group, so kindly join the group. That's why I'll be giving updates and etc, including the GitHub repo, because I've said we'll be working on mini projects, so that's why we'll be pushing our code. Yeah, so from my end, that's all. I have nothing else to say. Okay, I've been speaking for 1 hour 30 minutes now, and I'm not that person who speaks a lot, so nimeishiwa na mate manze. But it's been a good session. I'll end the recording there and wish you a good night.